These are notes from Elham's Math 251, section 2.2, part 2. Problem 11, they give you this piecewise defined function, f of x equals 1 plus x for x less than negative 1, x squared, x between negative 1 and 1, including negative 1 but not 1, and then 2 minus x for x is greater than or equal to 1. So 1 plus x, that's linear, slope is 1, y-intercept is 1, okay, but it does not include negative 1. If I were to plug in negative 1, I get 0. So an open circle at negative 1, 0. Slope is 1, so it goes down at a 45-degree angle. X squared, I know that's parabolic, so that's U-shape from negative 1 to 1, not including 1. So closed circle there. I draw the parabola. Now that's supposed to be an open circle temporarily, but it's going to get closed up by this part. Okay, so pretend there's an open circle here. That's closed because of that and that. But for this one, if I plug in 1, I do get 1, so that closes up the function. I know this is linear, the slope is negative 1, so it goes like that. So here's the entire graph. And the question asks, where does the limit as x approaches a of f of x exist? So the two-sided limit exists everywhere except at negative 1, it looks like. Everywhere else, the limit from the left and the limit from the right appear to be the same. Right? There's no jumps or gaps anywhere. Okay, so the limit of f of x as x approaches a exists for all reals except for negative 1, or all real numbers minus a set consisting of negative 1. 23 asks you to guess the value of the limit as x approaches 4 of ln x minus ln 4 over x minus 4. Notice we're going to say that the limit exists because we're not really plugging in 4, we're plugging in numbers that are very, very close to 4 from both sides. So I have a progression coming from the left, 3.9, 3.99, 3.999. That's approaching 4 from the left. And then 4.1, 4.01, 4.001, those are numbers approaching 4 from the right. Okay, so I take these numbers, plug them in, and this is what I get, 0.2532, 0.2503, 0.25003, and so on. And I plug in 4.1, 4.01, 4.001. And I got 0.2469, 0.2497, 0.24997. Right? So if you look at the progression, as we get real close to 4 from the left and from the right, it looks like we're getting really close to 0.25 or 1/4. So our guess is that the limit as x approaches 4 of this expression, ln x minus ln 4 over x minus 4, is equal to 0.25 or 1/4. 27, limit as x approaches 0 from the right of x to the x. So we don't have to approach from the left, only approach from the right side. So get real close to 0 from the right, 0.1, 0.01, 0.001. So punch it in your calculator. 0.1 to the 0.1 comes out to be 0.7943. 0.01 raised to the 0.01 is 0.9550. 0.001 raised to the 0.001 is 0.9931. Looks like we're getting close to 1. So our guess is that the limit as x approaches 0 from the right of x to the x is equal to 1. And 31, limit as x approaches 5 coming from the right of x plus 1 over x minus 5. So again, only coming from the right side, so 5.1, 5.01, 5.001. Okay, plug in 5.1, I got 61. Plug in 5.001, I got 601. Plug in 5.001 here and here, I got 6001. Well, these numbers are just getting bigger and bigger and bigger. So our guess is that the limit as x approaches 5 from the right of x plus 1 over x minus 5 is equal to infinity. Alright, so these are more notes for 2.2.